We know that the rule for gradient is change of y-axis, change of y divided by change of x. So this can be thought of as change is the symbol d stands for change, and this is dx. So dy by dx stands for the gradient of a Cartesian curve. Now the gradient of curves can be thought of as how does the slope of a mountain look. Now take a look here. The mountain is a very complicated structure. It has different slopes at different points. You cannot just say you're climbing smoothly. No, there is a crevices here, and then there is a turn here. So it looks a bit different at different points. So this is what a mountain looks like, and we can compare the slope of mountains, which is not constant, to the slope of curve. If you come closer here, you will see that how it changes here, and that's what happens. So in case of a curve, we don't have a fixed gradient. At different points we have different gradients, and we can find this complicated gradient using calculus, which is derivative differential calculus. When we differentiate, we can find the change of y with change of x for a very small amount, because you see, it doesn't matter what type of a mountain it is. If you consider it for a very small portion, if I zoom in and look at a very small portion here over here, it will look like a line for a very small portion. So that's what we are doing. We are trying to find a point for which the gradient of the curve is fixed, and that's how we find the gradient of the curve. But throughout it is not constant. It is changing, and it is changing from different points. Now on the other hand, gradient of lines are fixed. So we can think of them as stairs. Just like stairs have fixed gradients, we can think of them as fixed gradients. So for this particular line, we see that the stairs is fixed. It's climbing in a certain way. So the slope of the line is the same as the slope of the stairs. It is fixed. So we need a point to find the gradient of a curve. If you know the point, then we can find the gradient for a curve for that particular point, because there is no such thing as gradient of the entire curve, because the curve keeps changing direction. So when I say gradient of the curve, I mean what is the gradient of the curve at a particular point. For this particular point, it has one gradient. Suppose this is dy by dx. At another point, it would have another gradient, another dy by dx value. At another point, it would have another gradient, another value for dy by dx. For everything we need to know here, we need a point. A point is an ordered pair. Bracket open, x value, comma, x value, bracket close. So this is how it works.